Hello, today we're going to be solving some systems of simultaneous equations. As the thumbnail showed for this video, we're going to be using both elimination and substitution. A system of simultaneous equations has a number of equations. We're going to have two equations in ours, where we have some unknown variables and we want to solve for those variables. So we need to find values of x and y that satisfy this equation, that make these equations true. So taking these equations together, we shall label them to keep order. This is equation 1 and this is equation 2. And we're going to start by the elimination method. So we need to eliminate either the x terms or the y terms. Now, seeing as the coefficient of y in both of these equations is equal, we can simply subtract equation 2 from equation 1, and this gives us 7 minus 2x is 5x, 2y minus 2y is 0, 31 minus 16 is 15. So dividing both sides by 5, x is equal to 3. We can now substitute x equals 3 into one of these equations, 1 or 2. Let's substitute it into equation 2. So we have 2 times x, which is equal to 3. 2 times 3 plus 2y equals 16. Expanding these brackets, 6 plus 2y is equal to 16. Subtracting 6 from each side, 2y equals 10. So y is equal to 5. And so we have solved for x and y in each of these equations. Now, it's often a good idea to check your answers, particularly in your exam. So we'll say substitute these values into equation 1. 7 times x is 3, so 7 3s, plus 2 times y, which is 5. 2 times 5 equals 31. Expanding these brackets, 7 times 3 is 21, 2 times 5 is 10, 21 plus 10 is equal to 31, so we have verified that this equation is true. Now, for our second example, we're going to use the elimination method again, but before we do, we need to be sure that our equations are in standard form. Now, you see that x is on the right hand side here, we want to move it to the left hand side. So in general, what we want in a simultaneous equation is something x plus something y is equal to something. So rearranging these, remember we shall label them equation 1, equation 2. We can rearrange equation 1 by adding 2x to each side, so 2x plus 4y is equal to 14. Now, if you recall from the first example, we need to either add or subtract one equation from the other to eliminate one of the terms, either the x or the y terms. But before we can do that, we need to make one of the coefficients of either x or y equal to each other. So what we should do is either multiply equation 1 by 2 to make these coefficients equal, or multiply equation 2 by 2 to make these coefficients equal. Let's multiply equation 2 by 2, which gives us 8x plus 4y is equal to 20. So now our coefficients of y are the same. We can simply subtract equation 2 from equation 1 2x minus 8x is negative 6x. 4y minus 4y is 0. 14 minus 20 is minus 6. So x is equal to 1. Again, now we have a value of x, we can substitute it into either of these equations to find our value of y. So let's substitute x into this version of equation 1. Substituting x equals 1 into equation 1. We have 2 times 1 plus 4y is equal to 14. Expanding this bracket, 2 plus 4y is equal to 14. Subtracting 2 from each side, 4y is equal to 12. So y is equal to 3. Again, it's always good to check your answers in your exam by substituting these values into one of the equations that you haven't done yet. So this would be substituted into equation 2 just to check and verify that our calculations are correct. Now we're going to move on to the method of substitution. Before we do, if you're enjoying the video, click subscribe, like, comment and share. So with substitution, again, we label our equations. Equation 1, equation 2. Now, what we need to do with this system is we isolate x or y on one side of the equation here. So because this has a coefficient of 1 in here, it would be simplest for us to do that. So subtracting 3x from each side, we have a new form of equation 1, which is negative y is equal to minus 10 minus 3x. But we can simplify this further. If we multiply through by negative 1, equation 1 becomes y is equal to, let's put the x term first, 3x plus 10. So this is our new equation 1. And we can substitute this value of y into one of these equations and just express these equations in terms of x now. So let's substitute equation 1 into equation 2. We say 14x plus 2y, which is equal to 3x plus 10. 2 times 3x plus 10 is equal to negative 20. Expanding this bracket, 14x plus 2 times 3x is 6x. 2 times 10 is 20. Is equal to negative 20. Simplifying, 14x plus 6x is 20x. Subtracting 20 from each side, 20x is equal to negative 40. Dividing through by 20, x is equal to negative 2. Very good. If we now substitute this value of x equals negative 2 into our original equation 1, we can say substitute x equals negative 2 into equation 1. 3x, 3 times negative 2, minus y is equal to negative 10. Expanding this bracket, negative 6 minus y is equal to negative 10. Adding 6 to each side, negative y is equal to negative 4. So y is equal to 4. I'll say again, always check your answers if you have time in your exam. For our final example, we shall be using substitution again, but looking at these equations, we can see we need to rearrange them into the standard form. Again, standard form is something x plus something y is equal to something. So rearranging these equations, our new form of equation 1 is negative 4x, that's okay. The y term needs to be brought over here, so subtracting 33y, and the constant term needs to be on the right, subtracting 3 from each side, negative 3. For equation 2, we need to add 2x to each side, 2x plus 8y plus 8y. We need to add 9 to each side, it's equal to 10. Now, looking at equation 1, we can see all the terms are negative, so if we multiply through by negative 1, we don't change the value of this equation, so turn that into a plus, and turn this into a positive, and this into a positive, and our equation is easier to work with. Recalling our technique for substitution, what we want to do is get either the x on its own or the y on its own and express the equation in terms of the other variable. Let's do it for equation 2. So equation 2, if we subtract 8y from each side, we get 2x is equal to 10 minus 8y. Divide each side by 2, x is equal to 5 minus 4y. Substituting this value into equation 1, substitute x equals 5 minus 4y into equation 1. We have 4 times x, which is 5 minus 4y, plus 33y is equal to 3. Expanding these brackets, 4 times 5 is 20, minus 4y multiplied by 4 is minus 16y, plus 33y is equal to 3. Collecting like terms and simplifying, 20 minus 16 plus 33 is plus 17y is equal to 3. Subtracting 20 from each side, 17y is equal to minus 17. So y is equal to minus 1. There we go. Now to find our value of x, if we substitute y is equal to minus 1 into equation 2, we have 2x plus 8 times negative 1 is equal to 10. Expanding this bracket, 2x minus 8 is equal to 10. Adding 8 to each side, 2x is equal to 18. So x is equal to 9. Again, always check your answers if you have time. So let's summarize the technique. The first thing we need to do is rearrange into standard form. Standard form, which is something x plus something y is equal to something. Now bear in mind these somethings may be negative. So once we have it in this form, for the elimination method, we say that we need to remove either the x or y term by adding or subtracting one equation from the other. If they have different coefficients in each of these terms, then you may need to multiply or divide one of the equations to satisfy that. We can then substitute the resulting value into one of the other equations to find our value of the other variable. Now for the method of substitution, we need to isolate either the x or y term on one side, that is expressing one variable in terms of the other variable. Then we substitute that expression into the other equation and find the resulting value. So substitute this equation for x or y into one of the other equations.